Welcome to qnawire.
We are asked to solve for the bond dipole of the oxygen-hydrogen bond. In order to do that, we were given some information. First of all, we were told that the bond lengths of the oxygen-hydrogen bond are 0.96 angstroms. We were also told that the dipole moment of water is 1.85 degrees. Our first question, A, asks us to give the directions, the bond dipoles of the OH bond, and the overall dipole moment of the water molecule. In order to do that, I'm going to sketch the molecule. And the dipole moments for the bonds, look like this. And the dipole moment of the molecule looks like that. So those are the directions that all the different dipole moments show. B asks us to calculate the magnitude of the dipole vector. The dipole moment of the OH bonds. And I just used a pretty simple equation to do this, because I already had devise. I used this equals 2x times the cosine of, and then I took, since I had two angles, 1.4.5 divided by 2. Solving, I had 1.85 equals 2x times the cosine of 52.25 is 0.6122. X equals 1.51. And third, we were asked to compare to a table in the text our dipole moment to see if our answer was accord with the relative negativity of oxygen. And I looked up the HF. We just calculated the HO. We were given the HCl. The table they referenced was for halogens. So first, the electronegativities of fluorine, oxygen, and hydrogen. And they are, and I just looked these up at a periodic table, as follows. And then I calculated I wrote the dipole moment. I guess the bond dipole. And that would be 1.82 was given. And the hydrogen chloride was 1.08. And again, we just calculated 1.51. I wrote the wrong number down here. That should have gone here. There we go. And then that's not too far off. As the electronegativities decreased, the dipole moment decreased. This is probably a little closer to the hydrogen fluoride than we'd think, but it's pretty good. It's in accord with the relative negativity of oxygen. Didn't ask if it was perfect. It said if it was in the accord. Yes, in accord with the hydrogen halide bond table. We're done.